3, 2, 1. Hello everyone, this is the North America Math Contest Go Go Go. Today we'll be talking about the third question of the COMC question B. Let's talk about what we can do to solve it. In the diagram below, right triangle ABC has side lengths AC is equal to 3 units, AB is equal to 4 units, and BC is equal to 5 units. Circle center around the corners. Around the corners of the triangle will have the same radius, and the radius with center O has area 4 times that of the circle with center P. The shaded area is K pi square units. What is K? This question, when first seen it might be difficult and complex, but when solved it's not that difficult. Let's start. We can start from that. Since the angle of a center of O is 4 times than the center of P, we know that the radius of O is 2 times larger than the radius of P. You may be curious, you may be wondering how this step is achieved. So we said the area of the circle P is pi rp squared. While we said the angle of we said the area of the circle O is pi ro squared. So it is going to be, we know that p is 4 times larger than O. So we set it as this. P is equal to O is equal to 4. It's equal to pi rp squared, pi rp squared, pi rp squared, pi rp squared, pi rp squared divides by pi ro4, pi ro4, ro squared. Okay, it's equal to like this. So it's equal to, we cancel out P, and we are able to simplify this equation into RP divides by RO, radius of a circle P, radius of circle O, square is equal to 4. Which this thing is equal to 2, given both RP and RO are positive. Okay, so from this, we are able to know that the radius of P is 2 times bigger than RO. We can then, from this, we can set the radius of O as 2y and radius of P as y. Since circles centered around the corners of the triangle all have the same radius, which this part is just directly coming from the problem, we can set all circles with the we can set all circles centered around the corners as x. The radius of all circle, which in this case is going to be circle B, circle A, circle C. Based on the information of the image, we are able to see the radius of circle B plus the radius of circle LO plus the radius of circle A is equal to BA. The circle of the radius radius of the circle A plus radius of the circle P plus radius of the circle C is going to be AC. With this case, we can get radius B plus radius O plus radius A is 4, and radius A plus radius P plus radius C is 3. Since we can see in the problem that A, B, C are all circles centered around the corners. In this case, we have set both of them as x. So in this case, this becomes x, and this A becomes x, and C also becomes x. So we can see x plus 4y plus x is equal to 4. X plus 2y plus x is equal to 3. You may be very curious why here is 4y or 2y, right? Because I said it's radius. But if you look at it carefully, this part is not the radius for O, it's the diameter of the O. So it's 2 times the radius of O and 2 times the radius of P. So it should be diameter of O, right? Diameter of. Right. In this case, it makes sense. So in this case, because O has a radius of 2y, so its diameter is 2 times 2y is 4y. The radius of P is y, so its diameter is 2y. Y times 2 is 2y. So in this case, we're able to generate x plus 4y plus x is 4. X plus 2y plus x is 3. So which, in this case, it becomes 2x plus 4y is 4, and 2x plus 2y is 3. From that, we are able to yield that y is equal to 0.5 and x is equal to 1. You are maybe curious about how I get that. We can set this as equation 1, and we can set this as equation 2. We do equation 1 minus equation 2, so it becomes 2x plus 4y minus 2x, 2x plus 2y is equal to 4 minus 3, which in this case it becomes 2y is equal to 1, right? Because the x cancels out, so it becomes 2y is equal to 1, y is equal to 0, 5. We plug 0, 5 back to E1, so it becomes 2x plus 4, 0.5 is 4, so 2x is equal to 4, x is equal to 1. So x is equal to 1 refers to that the area under the shade, not the area under the shade region, the radius of a circle C, B, A are all 1, and the radius of P is 0.5, and the radius of a circle O is y is equal to 1. 2.5, 0.5 times 2 is 1. From this, we continue deriving. We can then use it to we can use the results we obtained from the previous steps to calculate the area under the shaded region. The individual angles of B and C may be hard to find, may be difficult to find because to solve it, you would have to use trigonometry to find the angle of B and the angle of C, which it is work. It's not difficult, but remember that this is COMC. This is not CSMC. If it's CSMC, I would highly recommend to use to calculate the sign value. But since it is COMC, right? This is COMC. The problem with COMC is that you are not permitted to bring in any calculators. Not permitted to bring in any calculators. So you can calculate sine 30, not sine 30 degrees. Sine x is equal to 3 over 4, or sine x is equal to 4 over 5 by hands, right? You can do that. The only way, but if you see it through careful observation, the angle of B plus angle of C is equal to 90 degrees. This is because angle of A plus angle of B plus angle of C is 180 degrees, while the angle of A is 90 degrees. So angle of B plus angle of C is 90 degrees. I'm a bit tired. So, from this, we can see that we combine this with the shaded area of A. Because since the shaded area of A is 90 degrees, ABC adds up to 180 degrees, which is, aka, is a semicircle of the radius 1. We can then end up with another semicircle with radius 0.5, aka is the radius of y, and then a semicircle with radius 1, which aka is the radius of 2y. So the semicircle of radius 0.5 is referring to the shaded area in circle P, while the circle with radius 1 refers to the shaded area of the semicircle O. So add those conditions up, we are able to get this equation. This part is the combined A, B, C. This part is going to be the semicircle. Let me see. It's going to be the shaded area of the circle O. This part is going to be the shaded area of the circle O, and this part is going to be the shaded area of the circle P. So for the first one, it's half pi. The second one is half pi, while the third one is 1 over 8 pi. So in this case, we're able to grasp a conclusion of 9 over 8 pi. Hence, since the problem wants us to express the question in the form of k pi, right? K pi. Where's pi? Pi is here, pi is here, pi is here, pi is here. K is equal to 9 over 8, which is going to be the final answer. Here we come to the end of our lesson, and I hope you have learned and enjoyed a lot. See you next week. Bye bye.